Today, MTD CNC have travelled to Middlesex. I'm at a company called Harji Components. This business has been going for many, many years, but has recently undergone some serious investment in these Doosan machines. You'll see they've got turning centres and also machining centres. The interesting thing about this business is the materials that they machine. Often we go into companies, it's all about aluminium machining, but today it's very different. It's all about hard metal machining. Tony, good afternoon. Can you tell us a little bit about Harji Components?
Well, Harji Components has been established for the last 15 years, predominantly for the oil and gas sector. And we've been heavily involved in that. We also do some work for the load cell industry as well, which is also very critical. And we machine hard materials, which is exposed to the elements of the sea environment.
And this was what I said in the lead into this video. It's a really interesting story because you're not just machining soft material. You won't touch soft materials. You want to be doing hard, complex parts, difficult materials, ones that others don't really want to get involved in. Is that correct?
That is absolutely correct. And we actually, from day one, we have been involved in this type of materials.
Tell us about the materials. Tell us which ones they are.
Well, these materials are Nitronic 50 HS, which is high strength. That's what it stands for. Nitronic 60 is also for the male and female part assembly component, as it were. And all these components go into a particular assembly called Christmas tree for the subsea environment.
And all these parts you're machining here on these Doosan machines, turning centres?
Every single component is machined here. Nothing goes out apart from deep hole drilling sometime.
And what I wanted to, or what we started talking about earlier, is about how you manage to get the surface finishes and achieve the tolerances that you do with these materials. And I totally get it. You didn't want to give away all your trade secrets, but some of the things you can tell us is how these machines perform and how your business is, getting the best results on those materials.
Yes, the elements of producing these components with very high finish is something that we have developed over many years of trial and error. And we do use the latest technology, and our main aim is to give grinding finish on turning. And these machines do very well for that.
Why do you think they achieve that, Tony?
It is all to do with feeds and speeds which we have developed ourselves.
And when you look at the machines here, you've got 2-axis lathes and you've got a Doosan machining centre as well, which is doing some of the second op works. You selected the GT 2100s for what reason? Why those models?
Very good question. The main reason we do this is that we do not want to occupy the turning centres for milling. On these materials, Paul, they will not work because the tools wear very quickly and they can very quickly go out of tolerance. So this is why we use the milling centres for that purpose.
It's interesting because a lot of companies now are trying to do as much as they can on one machine, yes. But you're very different.
We are completely opposite.
And would you put that as partially the reason why you're getting the best out of what you do?
We have tried different methods and we have come to the conclusion this is the best way of machining these hard materials.
Okay, now I want to know a little bit more about the Doosan story here. Yes. I get the fact that the tooling's a big part of it, but the machines can't be overlooked here. These machines have really delivered for you. Why did you select them in the first place? Because you've not just got 1, 2, or even 3. In fact, you've got 4.
Yes, the reason for that was basically we came to the conclusion with lack of space, we wanted the size of the machine, but we are able to produce all of our components on these machines. And also there was a financial side to it as well. They are very good machines, very commercially viable machines for us financially, and they give us very good performance and they have a good reputation.
Absolutely, totally second that. The reliability must be a big thing to you as well.
Reliability is good and their service is very good. That's very important. We cannot afford to have our machines standing idle for a week or 2 weeks because they can't give us the service.
Or even hours potentially. Let's have a look at, let's pick one of these parts up here.
Sure. me show you what basically component. This is a turned component, and this particular component is a material called Nitronic 50HS. This is for subsea environment for the oil and gas industry. These components are exposed to the element of harsh environment, and as you can see from the finishes, no matter which angle you look at, these are grinding finishes on these hard materials.
How do you find that material cuts? Does it chip well?
No, it does not. It nests, and that can cause a lot of problem to the machinist. And this is why they have to put a lot of stops to clean this swarf. Otherwise, they will leave swarf marks in the bores.
It looks like a tremendous surface finish on that, and not easy to achieve on a material like this, you've said.
No, it is not, and we try to achieve up to 0.4 minimum surface finish, and sometimes the component requires 0.2, and that's very high finish. In fact, that's way above grinding finish as well.
And you're getting that off the turning machine?
Only the turning machine.
Okay, let's have a look at another part that you got here. What about this one? I like this one.
Yeah, this is again a hydraulic coupling. This particular material is Nitronic 60. Again, it's for the subsea environment. And this particular component goes in an assembly where the HS go as well. So these are all critical components. These components have 100%, and I mean 100% inspected. And we also perform a leak test within the cycle, which is 100%.
I think what's interesting here as well is about machining these. I said about the chip flow and getting chips off the part. What about the vibration on the machine? Do you find any vibration when you're hitting the parts pretty hard?
No vibration at all.
And if you did get vibration, that would come out in the surface finish, I assume?
You will see it immediately, and that will tell us the insert is gone, because obviously it's been too hard. It can work hardened as well.
Again, we've said already, this is mainly about turning. Let's have a look at this.
Yes.
You do your second op work on the machine, Doosan Machining Centre, as we said.
Yes, we do, and this is another component. Again, it's for the subsea environment, no different from the others. It looks a very simple part. It's a collet. It's going to be split in half, and yes, it's again made of Nitronic 50HS. It requires that type of material, and it's again, although it's a simple part, but it's a critical part to look at.
It's a critical part which you've got to machine to a tolerance, you've got to get the surface finish. All of those things need, like you've already said yourself, a machine that's reliable, strong, and it's not just going to do this today and tomorrow, but it's going to do it over a period of years for you here at Harji Components.
Yes, it is important. These particular components are somewhat repeat components, and we do make in batches, not in tens of thousands, only batches of 50, 100 and no more. And these are very critical components for our customers, and we take a lot of pride in what we do in achieving those tolerances.
And if you had a word or two to say about Mills CNC that supplied these machines, you've already mentioned that their service is obviously everything that you require. How would you summarise their performance with the supply?
We would buy their machines again.
I don't think you really need to say any more, do you? But I am going to ask you one more question. We've looked at the turning centres, the machining centre, you've got a DNM there. Yes, that complements these quite well, doesn't it?
Yes, it does. In fact, we'll walk across there and we'll tell you a little bit about what we do over there.
Okay.
Let's go and have a look.
So as mentioned, this is the Doosan DNM. What are you doing on this machine then, Tony?
Well, I'll tell you a little bit about this machine. The reason we bought this machine was for the 4th axis setup as well on this, and that's what we wanted. And we are doing deep hole drilling on this particular machine on a component which is made out of 17.4 pH, very hard, 39 Rockwell hardness.
What's the diameter of the drill what's the diameter of the hole you're trying to create?
6 mil. 6 millimeter is the diameter of the hole, and we are going 320 millimeter deep.
Right, right the way through. So you're going right the way through to the bottom of the part. Yeah?
We are going right the way through, and it's going to have an interrupted cut as well. And it just goes to show how carefully we're going to go so it doesn't wander off.
Okay, so you're kind of pecking this.
We don't pack too many times because the carbide drills can break very easily when you're doing deep hole drilling. So maybe 3 times, no more, and with the through coolant.
I mean, that's a pretty long drill there. What sort of, what's the life of that on the, and how many are you doing?
We should be able to hopefully do the whole batch, which is a batch of 50, if you're careful and if there is no swarf interference with the drill, they can break.
And I'm assuming it's just a clearance hole.
It is a clearance hole. That's why there is a bit of a tolerance there that we can manipulate.
And the Doosan, the DNM machine handles it pretty well. Obviously, you wouldn't be doing it. But what's the speed of the drilling operation?
The speed on this, I think, is about 1500. The 0.8 feed rate in this.
Nice machine. As pleased with this one as you are the turning centres?
We are very pleased with this machine as well. It has done some very, very good work. And we have mainly used the 4th axis on this. And we do a lot of solid start and finish threads on this, which is a beautiful piece of engineering.